Okay, so the roof is open. Here's the boltwood screen up. Wind is calm. The next thing I do is I'm going to open the telescope control system, connect to that. And basically all I'm doing with this is turning the mirror fans on. So you see there's a lot of features on here that I don't want to spend time going into. Over time, I basically have settled into pretty much using just the mirror fans, and I just turn them on possibly an hour or so before the session begins, depending, but I don't know that really is that critical. I do run a fan in the observatory when everything is closed up, which can help some. But I really haven't seen a huge difference, say between 1 and 2 hours of cooling with this system. The other thing that I am interested in is the humidity. We talked about that earlier, but the humidity, this is what the mirror is seeing. So that's something that I really don't want to get too far above. I would say 70%, because then you're going to have a definite dew situation on your mirror. So the fans are on, and that pretty much stays on for the duration of the session. So we'll just minimize that. The automation software that I'm using, this is CCD Autopilot. And usually this is the last thing that I open, because what I found is while you can have the automation program pretty much do anything you want it to, including turn on your mount, your camera, etc., etc., I find that, and you will find certain things you may want to make sure get started properly before the session begins, because you can have a situation where, for example, turning on the camera, it times out because there's a driver that wasn't updated, or maybe there's a USB connection or something, and you might have to reboot the camera. There may be some other equipment things that you want to make sure of in terms of the start, because the one thing that's very frustrating is turning this program on, having it run everything, and then getting up in the next day only to find out that there was some error that occurred that caused the entire session to not happen. So I tend to do that first before linking everything and getting it started. But I did want to open this first to illustrate the plan for the evening. And so what I'm going to do is just link to the SkyX, which is what I use for my planetarium program and mount control, etc. We'll go through this in a little more detail later, but for tonight, like I had mentioned, the moon is going to be is just shortly past full or waning, and so it is going to be coming up around 10:30. So we're going to do a narrowband session on the fireworks galaxy, that's NGC 6946. So if I'm just going to center the sky for now, so we can see what it is we're going to be doing. So this is basically the field of view of the camera. here's the main sensor, and here's the guider. I use the self-guiding filter wheel, and this is the guide star that's centered in the guider. So this is basically the it's a magnitude 8.69. So that basically is what we're going to be doing. And here you can see your galaxy is in the center here. It's about 11 arc minute size, and this is a 16803 sensor, so it's huge. And we're just looking at this. So some of these projects, obviously, we're going to trim out, a bunch of this here. But it does give you some flexibility because we're using a self-guiding filter wheel. In terms of positioning the object, we could conceivably have the galaxy here if we didn't find a guide star in this position. There happen to be several that are readily available. So anyway, this is what we're going to be doing this evening. I'm going to go back to autopilot now, and let's just disconnect for now because, as I was saying, this is pretty much the last thing that I do. And the next step after turning on the equipment and turning on the telescope fans is to connect the telescope, and that's what we're going to do here. So we're connecting the telescope, and tracking is off. Let's see what the naked eye view is here, and let's look south. And so here's basically a telescope position. That's where it tells you what it's doing at this point. The tracking is off. We're now going to connect the camera. That's the auto guider. Let's do the camera here. And auto guider, let's move that over here. And so let's connect the camera. So this is, for my system, this is what seems to be a little quirky. Sometimes the connection times out. Now it apparently has connected successfully. The one thing that we're going to do, we're going to try to do is take some sky flats, and sometimes what I'll do is I won't actually incorporate the dust flats into the session, because I don't want to, if I try to cool this camera down to minus 20 degrees and it's 80 degrees still, I don't know that, I'm sure it can handle it, but I don't know that I want it to be powering it, whatever, 80% plus for the entire duration of the flats. So I'm not going to set the temperature right now. If I incorporated the flats into the session for the entire night, I would have to set the temperature ahead of time, because it's going to run the whole session that way. So I'm just going to leave it for now. When it powers on, it sets to basically 0, and the power will come down to maybe about 50% or so. So we're going to leave that for now. So we have the camera, the telescope mount is connected, and the camera is also on. Notice how the telescope is now tracking. Normally does that, but once we connect the automation software, we have set it so that it will keep it not tracking until the session actually begins. Next thing we're going to do is connect the focuser, and now what I use is Focus Max, and so that's going to open, and when it opens, it will automatically connect to the focuser, which is a rotofocus. That's what I use with the 16-inch. The focuser seems to work more consistently if I home it before the session begins. So I'm going to home the rotator, and you can see the panel turns green here. I'm going to home the focuser too, and the position is 0. So this is the other issue here. If you were to just have your automation software connect everything and just open everything and start everything, you have to be certain that it's going to that your focuser is going to be reasonably close to the focus position, and by that I mean within the critical focus area, so that the focusing can occur efficiently. If you're way out of focus, it may actually struggle to find the actual focus position. And the other thing is, if you are going to take flats, which I'm going to do in a minute, you're going to need to be pretty close, or again within the critical focus area or focus zone, which for this system it's a F7 2800 millimeter. The critical focus zone is it's like 150 microns or so. It's very forgiving. But this, generally from experience, I know this position here, 12,000, is good. So that's what we're going to do there. The final thing we do is open Autopilot, and I had already opened it previously. So we're now going to link to the software, okay? And all of the executive programs work pretty much in similar manners with respect to linking to your different control programs, your focus program, and your camera program, etc. I'm not going to spend time going into the specifics for Autopilot, but we're connected here, and it kind of tells you what software we're using, etc. We're going to go to the Session tab, and we're going to be working on the Fireworks Galaxy. That's what we have active here. I have it set for the actual light frames to start at 10 o'clock tonight, and the dust flats I do have set, but like I said, I'm not going to run the session yet, because again my camera's not cooled down all the way. I want to typically wait until it's a little bit after dusk for the temperature to come down more, so the camera doesn't have to work that hard. But these headers tell you, okay, we're going to do dust flats. I'll show you how that works in a minute here. We're going to do an hour's worth of dark frames. We're going to shoot for the hydrogen alpha filter tonight. We're going to take these 15-minute subframes, and that's the 900 seconds that you see here. So we're going to do our dark frames. Again, we got to make sure we cool the camera down before we actually start the main session. Our light frames, we're going to take, this is going to be pretty much the whole night. This will give us, hopefully, if we can get at least half this many, we'll be in good shape. Various things happen. The seeing goes up and down. We'll go through that later on. So we're going to go through till about, you can see it ends, projected to end around a little after 4 a.m. By that time, you're going to approach astronomical dawn. And we are going to do dawn flats. So we're going to do, because we have a rotator, and you have east and west, I use a rotator for this system. So in the morning, we will take the west side flats, and tonight, in a minute or two, we'll take the dust flats. The other things that I'll just show you briefly here. When the session's over, you can see it says the telescope will park once the flats are done, but the roof is not going to close. The other thing that happens is it will allow the imager cooler again to go back to 0, and the guider is also integrated with this camera, so that will return to 0 also. For startup, we don't really have anything set up there. Focusing, you have a number of options. The one thing that I like to do for this setup is use an offset. Use the offset method where you actually focus with your luminance, and then the system has figured out how many steps are required to get to the focus position for all the other filters. So this way you don't have to focus through these dense filters. That can be very difficult to do. And for this system, again with a fairly large, forgiving critical focus zone, this actually works pretty well. And how it figures it out is you pick a star and have the camera focus with each one of the filters, and it goes through that 5 times. Then it calculates the median values and generates this sort of data here, and so that allows you to do that. So you'll see when we actually start the session, the full session, it will demonstrate that. So for right now, what I want to do is, since it's the sun is almost setting, what I'm going to do is we're going to go to this Dusk Flats page here, which you see, and we haven't actually formally started the evening session. I'm going to click on this Flat Frames now. Okay, so it's being done. Remember, the camera has not been cooled down to -20 yet, so I'm going to do this, and then we're going to let's see if we can so the nice thing about these automation programs is it actually tells you, it's almost like having some kind of a supercomputer, almost like a HAL 9000. I call it the HAL 10,000. It actually tells you what's happening. It's waiting to start Dusk Flats, waiting for twilight, telescope is unparked, but the scope is now slewing. So let's see what that looks like. Telescope is slewing, you can see that. Typically goes to to what's called the null point, approximately. So it's pointing to that location, and it's going to take the flats. Okay. We want 15 exposures. By experience, that's typically been about the maximum that it can do, because remember, the sky is continuing to change. It's continuing to get darker, and so the exposures have to keep adjusting to stay within a certain brightness that you figure out when you're setting all this up. So it is rotating to the position defined by the field of view that we saw earlier, and that's what it's doing now. Once it's moved there, it's going to, the target ADU count we have for this camera is 25,000. So we're going to see what that looks like here. Let's pull the exposure out, and it's exposing your flat. And so here you see the field of view here with these dust donuts. That's typical for a flat. And it's going to take 15 of those and continue to work until it reaches a maximum of 30 seconds. Beyond that, tells us that it's too dark and it has to stop the acquisition.